Thanks for joining this DaaS deep dive, AWS, Azure, GCP, performance, user experience and cost. 2024 edition means there's a lot of new data as well. I'm Ruben, Field CTO at Dision, and in the next, I would say 30 minutes, we'll dive deep and wide into performance, user experience and cost analysis. There are 6 topics here. I'll differentiate between performance, system performance and user experience, overview of the apps and tools we use, and then dive deeper into like cloud PC data, cloud workstation with GPU and various GPU apps, and cloud workstation with GPU and various architect, engineering and construction applications. And then I'll share some interesting data around studies we did and the data you can use out of that. So there are 2 main themes. One of them is system performance and the other one is user experience. And if you combine these 2, and that's, I would say, something you need to do, that provides like the insight, like what do you need to get the right user experience. If you look at the remoting protocol itself, a key element in user experience, and you have a shitty like system itself, like a guest VM or a host, then user experience is not great either. You look at the other way around, if the system is well sized and operating well, but from a protocol and network perspective, or maybe a client decoding side perspective, it's not designed well, then still you have a shitty user experience. These 2 worlds are sort of hand in hand and should be combined. And insights in system performance and user experience is what I will cover in this session. If I would ask you, what does this mean? Actually, this is a screenshot we took, I think a year or 2 ago at ITIL Disrupt. And this is just the decibel meter. Does it say anything about my user experience during this concert? Well, it was loud. That's about it. There's no audio here, which is totally fine. Doesn't matter for now. But you can see that this is like the recording, like the video recording, my user experience watching this like mini concert. Combine that with like the decibel meter. That tells something, right? It was nice if you look at this, or if you like this type of music, and it was loudish as well. That is system performance and user experience combined. Why is it important? Well, that is what the actual end user experience will give. There are 2 major questions we'll address in this section. What is the performance and cost effectiveness of like DaaS instances in Amazon, Azure and Google? And what is of the user experience? Normally I present together with Benny Trich, and he goes deep into this topic, and we have also more time. My main focus will be this one here, but I will give a little bit of insights around this analyzing user experience piece as well. So focus, first of all, is system performance. Why is it important? Well, if you look at DaaS like a pro, another community, and a survey we run yearly, if you ask the questions, what are the biggest challenges in your organization caused by or adopting desktop as a service? It's cost and performance. And guess what? These 2 are addressed in this section. So what kind of apps and tools do you need, or what kind of apps and tools did I use to get insights in system performance? This is just a short list. I will go a little bit deeper a little bit later, but this is the list we use to get performance data of the machine itself or the machines itself. And these apps are specifically for like design and visualization type workloads. While these are more, I would say, generic. You can download them and easy to go. For these, sometimes you can download them for free. Otherwise, you need to sign up for a trial like the Autodesk ones and run specific benchmarks with these apps like Inventor and Revit and VRED. So we use Amazon, Azure and Google, and we use Dision as sort of the orchestration engine for these platforms. And we use Frame remoting protocol to access these workload machines and run different applications. And that the Frame remoting protocol will tie back into the user experience story, which I will address a little bit later. But all the data, all the system performance data is applicable, of course, to Dision Frame, but also to Citrix, to AVD, to VMware, if the workload machines are running on that platform itself. So what are the observations and lessons learned? Well, first of all, Benny and myself, we spent probably, I would say, 5 months in total, not only this year, but mostly last year in collecting all this kind of data. So it's not just, hey, spend a couple of weekends or a couple of weeks or a couple of days in getting that system performance data and getting the user experience data. No, it is really like a lot of work. It is fun, you learn a lot, but yeah, the end result I will share is massive. So that is also the challenge with this kind of data. It will be a sort of information avalanche to digest. It will not work, which is totally understandable and fine. But it's still good to have that data, because with that data you can make your own decisions. And these decisions are based on, I would say, 3 major questions. Ask yourself, what am I looking for? What kind of machines? Of course you can compare, but are you looking for like on a storage side, performance, on a CPU side, on a GPU side, or maybe like one level higher in the abstraction layer? Maybe I'm looking for I need to have this 2D CAD application. I'm looking for the right machine for that workload. Or I want to compare Azure with AWS and Google, because that's what I'm looking for. And I want to know which type of machines apply to my use case. So it's important to paint like the context of the topics you want to address. And also connect it with the use cases you have in mind. So these are all, in my opinion, obvious things. But sometimes you forget when you look at this amount of massive data, okay, what I'm looking at. Well, ask yourself what I'm looking for. What kind of machines I'm looking for. What kind of workload machines do fit in my use case. So there will be 3 major segments. One of them is cloud PC, so with CPU only, or cloud PCs, or virtual desktops in the cloud running without a GPU. And we use a couple of benchmark tools to get insights in that. One of them is CPU-Z. You run the benchmark single-threaded, multi-threaded. That gives a number. You run this benchmark multiple times, and that will produce like an average number. That will be added to the Excel sheet. You run Cinebench R23. Single-core, multi-core provides a number. You run that test multiple times. You average out. That number will be added to the Excel sheet. Older versions of Cinebench, like R21 as an example, also is using like the GPU for some sort of rendering. But that's what we use as well. We use Login Enterprise, sort of a standalone version with the EUX score. The EUX score of Login Enterprise is using like the resource, like all the resources of the machine, so CPU, memory, storage. Doing its magic and produces a number like 804 you can see here. Everything below, I would say 6 is like no-go area, don't use that at all. And everything, I would say above 7 is, okay, this is like a decent machine. And you will never get like a 10, or that's what I understand from that developer. It's like a hockey stick with a never-ending ceiling. Even with like the fastest machine you have, maybe you have 9.5, well, you will never get like 10. And this workload is also designed for like the task worker. So don't expect like a GPU type result with a number with the EUX score. Then we use Benny Stritch EUC score. Don't be confused with EUX and EUC score, but this is like EUC score. Benny has multiple sim loads, and we use like the sim load 3. And these like are the benchmarking sim loads. So we use multiple of them in the results as well. Then you get a massive Excel sheet. And this massive Excel sheet, there are, I would say, 4 major components. And likely with a live stream it's tougher to see, but with a recording it will be sharp. And also like the download of the deck, it will be sharp, because that's like the picture is sharp. But here in, I would say, white or whitish are all the machine types. That is the CPU, the base clock speed, the single core max speed, the amount of vCPUs, the amount of RAM, what kind of storage type I'm using, standard SSD, premium SSD as an example. The size of storage, if there's a GPU, well, in this context there's no GPU because the context is without GPU, cloud PC without GPU. What kind of display resolution is being used, full HD in this example, and what is the operating system. And you see Win 10 here and Windows Server here, and that's mainly because on AWS and Google it's still very tough, challenging to run a client OS in like public cloud. Has nothing to do with technology, but all to do with licensing. That's like this sort of white-ish angle here, like machine insights, instance types insights. And then you have here in dark blue, with a sort of heat map in colors, CPU-Z to EUC score with IOPS. These are like the benchmarks, or some of the benchmarks I mentioned earlier. With the numbers, and each number represents the average number I shared earlier. Then here is price, and price is in dollar per hour. It's on-demand pricing, so it's not custom pricing or your own pricing with like discounting. It's across all regions. That is also interesting data. The Windows OS is included and the storage cost is not included. So that's like the data here. And then you have here in sort of purple the price, the performance price ratio. I wouldn't focus on now on this, but also interesting data as well. So a lot of data to digest. Again, understand okay, what am I looking for? Do I want to compare Azure with AWS or Google? Do I want to compare public cloud with on-prem? Do I have a very specific application with this kind of characteristics and I want to know which machine type fits best? All great questions. That's, I would say, your major question. And this kind of data then helps in answering that question or questions. Well, you can zoom in a little bit better. But the essence is like different machine types here. On the Azure side, I often see like the D series V5 in like single user or also multi-user environments. On the AWS side, like T3, M6 are like the two major family members here. And on the Google side, you have N1, A2, N2 with different CPU types, different clock speeds as well. Overall lower clock speeds compared to Azure and AWS. And overall also faster storage. Right now we don't talk about storage performance in this session, but Google is doing really well from a storage performance perspective. And then here, just funny, is I also added my own physical workstation here and a Nutanix HV environment running on OVH. So it's nothing to do with like these public cloud comparison, but it's fun to see what kind of performance I get with my physical machine, especially with a GPU workload, and also what kind of performance do I get with this like OVH 4 CPU 8 gig of RAM machine, just as sort of reference. And maybe we'll go deeper somewhere this year on OVH or other sort of managed data center providers. We'll see how that will go. Again, go deeper into like the different apps, as you can see here, and the pricing, as you can see here. So what are the sort of observations? I would say on the Azure side, use V5 machines, not V4 or V3 machines, or maybe like V2 if that's still applicable. Often I see still V3 being deployed, like D series V3. Use V5 when available, and often they are available. It's like 25% better performance, especially on the CPU side, and even a slower, a slightly lower price compared to the V3. If you look at AWS, use the M6i instead of like T3. Same price, better CPU. Well, you can see it here as well. On the GCP side, it's overall it's a cheap instance type, but from a CPU perspective, they're using older generations of CPU. So if your workload is really sort of CPU heavy, that's something you should keep in mind as well. Alrighty, let's switch gears to like the second sort of bucket. Second bucket is all about cloud workstations with GPUs. And we use different apps. We use Blender in benchmarking mode, as you can see here, with like 3 sort of sample applications. We use SpecViewPerf, and SpecViewPerf is a set of apps like 3D Studio Max, CATIA, Maya, Siemens NX, SolidWorks. All these apps are sort of bundled into this benchmarking suite. You don't need these apps. You don't need the licenses for these apps, and you can still run like SpecViewPerf on your machine, and it will produce a number, as you can see here. Run it multiple times, average that number, add that number to the sheet. Massive amount of data. You can see already the sheet is like massive, massive, massive. Same story, white are the machine types, dark blue are like the applications in different modes. Blue here is the price, and then in purple it's like the price, the performance and price ratio. Sometimes you see fail here, like in blue, there's like a blue color here. It means that that application failed to run on that machine. It could be, like for instance, this one here is a Google machine. Let me zoom in a little bit better. It's probably better. It fails maybe because the machine itself is just too light on CPU. Then the app fails, nothing to do with the GPU. Because the same machine type, but now a little bit beefier, runs fine. Still not a great performance because it's red compared to others in this sort of column, but it runs. You can see the same here in fail with the AWS G4 AD machines. And AD machines are like the AMD 510 GPUs. This set of app, Blender GPU, doesn't run with that instance type. Not sure why. Maybe it's application a compatibility issue. Maybe it's a driver issue. I don't know why. That's a different conversation, but it fails. Also interesting to see is that the NV6 ADS A10, that's the A10 NVIDIA GPU, sliced, so GPU partitioned, like the entry-level machine, also fails with that. But if you use a beefier machine, like the NV12 or the NV32, then it works well. Not sure why that is the case. That's a different conversation. But there's something to keep in mind. Like, interesting. Many people think, okay, I will use the entry-level machine because it has a GPU. It doesn't mean that that slice of a GPU will serve its purpose for your use case. Again, back to the question, what do you want to achieve? Alrighty, third bucket is the AEC use case. Architect, engineering, construction, CAD, BIM, visualization use case. Different set of applications. You can download Unreal Engine through like the store, and then you can add like a sort of, I would say plugin, but like a sort of an application Audi car configurator. It's free to use as well. And you can just add that to the Unreal Engine project. And then here in the settings, you can enable frames per second. And then if you capture the frames per second with another tool, like Fraps as an example, that's what you can see here. You see, okay, this on this machine, I get close to 39 frames per second on the host side. Not on the client side, but on the host side, okay? Capture that, add it to the Excel sheet, well, run it multiple times, average out, add it to the Excel sheet, and then you get a number. This machine type running Unreal Engine will get this type of frame rate for the user. And that's what you see here in action. So running Unreal Engine, starting in sort of benchmarking mode. And then if the car is sort of finished, then you see like that's the number I will capture, 24. Not sure if you can see it, but I can see it clearly on the screen here. 24, so I will capture that number. I run it multiple times, capture the number, and add it to the Excel sheet. Other app, Autodesk Inventor. There's a plugin called InfMark, and InfMark will do a benchmark of Inventor. All kinds of tasks in Inventor. You can use a trial version of Inventor, of course, your current version, like your production version. Add the plugin, run the plugin. It will do its magic for half an hour. It will produce a long list of sort of numbers. You add the numbers to the Excel sheet. Avalanche of data. VRED, similar story. Rotate the object, capture the frame rate. You can run it in multiple modes, like in ray tracing mode, and capture the frame rate. This one is Autodesk Revit with RFO mark, a sort of industry standard benchmark for Revit. It's doing all kinds of different tasks within Revit. There will be a long list of sort of results. Run it multiple times, add it to the Excel sheet, good to go. Keyshot, in Keyshot there's a benchmark mode, run it, it will render, it will use the GPU heavily to create a photorealistic sort of image. It will take an amount of time, number, add the number to the Excel sheet, good to go. Same for Enscape, same for V-Ray. Long list, massive list of Excel. Same story, machine types here, the same GPU machine types as we talked before. In dark blue here, long list of apps. Long list of apps from V-Ray, Keyshot, Revit, in different sort of running modes, updating the object, creating the object, exporting the object, rendering the object, all that kind of stuff. In VRED, in aliasing, no aliasing or extreme high aliasing, mode Enscape, Unreal Engine in real-time ray tracing on, real-time ray tracing off, and then Inventor in different modes with the InfMark plugin. Numbers again, sometimes it fails. As I mentioned earlier, why? Could be driver, could be a combination of driver and application. Could be that the partition itself is not suitable for that. Simple example here, like the NG8 or the NG family, Azure NG ADS V620, that's an AMD-based GPU. They don't support NVIDIA RTX. Guess what? Why? It's AMD, not NVIDIA RTX. So that's why it's failing. That's the easy one. There's a massive, like in-depth, but still very readable article, probably 6 pages, available at AEC Magazine. That magazine is designed The whole purpose of that organization, AEC Magazine, is to inform their audience, which are like companies who build and design bridges, airports, all kinds of cool stuff, and create a special report about workstations. And there's a special report created around cloud workstations. And that's the link directly to that special report. And that explains many of the things I showed, but in a more digestible way for the AEC sort of community. Not the EUC community, but the AEC community. So what are the observations here? The older generation of AMD-based GPUs, the MI25, in Azure it's the NVV4 machine, is, I would say, it's an old generation GPU, and that, I would say, says it all. The GPU itself is not great. If you look at spec view perf, low 3D performance, no video encoding. If you look at the like entry level and medium level slices of GPU, limited in the amount of frames per second. If you look at the entry level, so yeah, skip, I would say, in most of the scenarios. A machine I like a lot is like the T4, the NVIDIA T4, like the Turing 4 based GPU, like the NC8 or sometimes the NV4. So of course it depends on the use case, but this machine is like a very powerful machine. It's a dedicated GPU, so no slicing of GPUs. The GPU you get is your GPU. It's a nice machine, I would say. Then you have the NV ADS A10 family with the NVIDIA A10 GPU, slicing of GPU. This one is great. It has a high clock speed, as you can see here as well. So this one is the instance type with the highest clock speed at all in Azure and AWS and Google from an EUC perspective. So if your app really benefits from high clock speed, like single-threaded clock speed, this is a very, I would say, powerful machine from a CPU perspective. But the entry-level slice of GPU, don't be fooled by, okay, I have an A10 GPU. No, it's a slice of an A10 GPU, and it's also sort of, you're not sharing resources with others. You always get the same performance, that is great, but it's a slice of a GPU, maybe 1/6 of a quarter of the GPU, so you also get the performance of that quarter of the GPU. Not only a frame buffer, but also like streaming cores and so on. And then you have like the newer family members, like the AMD V620 GPU, really competing with like T4 and A10. It depends on the use case and application, but sometimes beats it, sometimes the other beats like the V620, but it's like very, very close. And often the V620 in general, I would say, beats the other two. Price, I expected when the instance type was announced, that the price would be like lower than the NVIDIA-based machines. Unfortunately, that is not really the case. I thought it was lower because there's no NVIDIA GPU licensing involved in the AMD machine, obviously. But it seems that the performance watt, or like the power consumption of the GPU, is relatively high, and that's like a massive impact in like the cost in the Azure context. If you still have like the old M60 NVIDIA GPU with the NV6 or the NV12, it's time to switch anyway, if not done already, but time to switch anyway and go like for this. Try this one as first, or maybe like a slice of a GPU, if that fits the use case. On the AWS side, what I like is this machine, the G4AD. It has a dedicated AMD V520 GPU. Very good performance-price ratio. Not the highest performance, but still a very decent price if you look at that machine. I see this also in edition context a lot. A lot of like 2D and like sort of entry-level 3D design companies are using this machine type. That's what I see. On the AWS side, the G5 has an NVIDIA A10G. Outstanding performance compared to Azure. It's a dedicated GPU. It works really, really well. GCP, one massive advantage. They are the only one today which supports Ada Lovelace in the EUC context. But still their CPU performance is limiting, like the clock speed itself. And then, of course, with always the discussion with GPUs, what kind of GPUs are available in which regions, What is the real availability? What are your service limits? What are your quotas? That's always a topic of attention, sometimes like massive attention. There are 3 sort of handy websites to use, like on the Azure side, on the AWS side, and Google side. We'll share the slides, of course. But these 3 websites will help in finding out, okay, which instance type is available. Is it available? Sometimes it's being announced, but not available yet. And sometimes it is available, but not in a region you want. So that kind of insight is helpful and important. And there are 3 handy websites I did share here. And this is a simple screenshot of the Azure one, where you could see, I did select a couple of regions here, like the NC-AST4, like the NVIDIA T4 GPU, the NG V620, the AMD V620 GPU, the A10 GPU, and the like older generation AMD. You can clearly see it's not like check marks all over the place. That's one. Sometimes you see like a different icon here, like it's not there yet, but it's coming in Q2, Q3, whatever the number is. So this kind of info is helpful if you, well, design your cloud workstations. Also interesting, that's what you also will read in the AEC magazine, is that many of the cloud workstations I presented are beating physical workstations. So the question the AEC magazine folks ask, okay, is the cloud workstation really usable? Does it beat the performance of physical workstations? And what does the user experience look like? The cloud workstation is running in the cloud. I remote into that machine through a remoting protocol. What does the user experience look like? From a system performance perspective, we're still in that bucket. Many of the cloud workstations beat 2 to 4 year old CAD/CAM workstations. But also, the cloud workstation cannot beat physical workstation. If you really look at the extreme high-end performance, like my physical workstation at home, you saw that in the Excel sheet, that machine costs probably, I would say, 15,000 euros, something like that. Has a massive RTX A6000 GPU. It's really tough to beat that GPU and that machine with like NVMe storage and the amount of cores if you look at cloud workstations. Do you need that machine? Good question. That's the starting point of the whole conversation. And performance is not the only key topic in decision making. Maybe you want to have 3 cloud workstations at once for a project, and that project ends next week, and then you just need 1 machine. Or you need to work from everywhere. You want to access the cloud workstations from everywhere. Or you have contractors. You want to use bring your own device and access these type of machines. So there are many other reasons in deciding, hey, does cloud workstation, cloud PC work for me? Or do I stick with like physical PCs and physical workstations? A couple of minutes left. So most of the time I spend on system performance, or I would say 95% of the time I spend on system performance. The other topic is about user experience. And as I mentioned, normally we have like 15 minutes extra, and then Benny takes over to talk about and show user experience. That's how it normally is. And Benny is sitting here, so he's smiling from ear to ear. All good. But I just want to explain what we did. Don't go deep, but just explain what we did, and then you can also find the results yourself. So this topic is all about user experience. Remember the video of the concept itself? That's the user experience. System performance is the decibel meter. So what we did, we spent a lot of time, as I mentioned, on AWS, Azure, Google, GPU and CPU instances, but this particular one with GPU instances, these are the apps we use. And now we add network configurations to it. Local area network, wide area network, 248 Mbps, 1060, 110 millisecond round trip latency, full AZ resolution, 4K resolution, YFV 420, YFV 444, that's the color space. End result, a couple of sleepless nights, but also a lot of interesting data, 40 studies, and more than 200 sort of scores. And how do these scores look like? That's where EUC score kicks in. This is just a screenshot of the website I will just share in a couple of seconds. This is the actual screen recording of the endpoint itself, the end user's device. We use hardware grabbers, frame grabbers to capture what the end user will see on the screen. And this is all telemetry data. We have 8 blocks of telemetry data. Right now, this is sort of frame-specific telemetry data, CPU with frame network latency, frame average quantization parameter that says something about compression, the frame rate, what kind of GPU memory is being used, what's the GPU 3D engine doing, what's the bandwidth used. So all kinds of interesting telemetry data. If you just look at the telemetry data itself, it is like looking at the decibel meter. If you look at the user experience side of things, it is looking at the video of the concert. If you combine these two, interesting details, interesting data. That data is available here at ux.digion.com. Let me go to this one here. That's the website, how it looks like. I'll not go into details here, but that's where all the sort of studies kick in. You can see it here. On AWS, on like Azure side of things, on the Google side of things, with all kinds of different machine types, in different network configurations, in different color space configurations with different resolutions. And that will help big time in investigating, hey, what works well for my particular use case. And with that, I would say big thanks for watching, for listening, and see you next time. Thanks.